We use design patterns, the time tested practices to build better software. But what if you pick or formulate a particular design pattern that appears useful to you in the initial stage, but will slowly lead you into a trouble or into a complete mess of code base? Will you still document it? Yes, you can, but as a bad experience, and to learn from that, to not repeat that in the future. So instead of a pattern, now it's an anti pattern to you or to whatever goal you are trying to achieve, be it in software engineering, businesses, or any other domain in life. Somewhere in 1995, programmer Andrew Coing first coined the term anti pattern in his article. And he mentioned that an anti pattern is just like a pattern, except that instead of a solution, it gives something that looks superficially like a solution but isn't one. So the core idea was that an anti pattern is something that seems like a good idea when you begin, but slowly it leads you into trouble. By the year 1998, anti patterns became a more popular topic of discussion with the launch of a book called Anti Patterns Refactoring Software Architectures and Projects in Crisis, authored by another gang of four authors called William Brown, Raphael Melville, Skip McCormick, and Tom Moby. They were called the Upstart Gang of Four. So, in a nutshell, anti patterns can be specific, repeated practices in software architecture, software design, and software project management that initially appear to be beneficial but ultimately result in bad consequences that outweigh hoped for advantages. This is something that makes anti patterns something different from other ideas. It looks like a good solution in the beginning, and that's the biggest danger of it. Since it looks good, some people take that path, but after some time, after pursuing that path for some time, they get to know that the path is not right and our decision was a bad decision. So, not only knowing what an anti pattern is, but getting out of that trouble is important as well. It is also useful to remember that the same solution can be a good pattern in some context and an anti pattern in others. So, the outcome of a solution or a pattern depends on the context in that you use it. And anti patterns can arise in any phase of the software development lifecycle. And as Jim Copeland famously said, the study of anti patterns is an important research activity. The presence of good patterns in a successful system is not enough. You also must show that those patterns are absent in unsuccessful systems. Likewise, it is useful to show the presence of certain patterns, anti-patterns, in unsuccessful systems and their absence in successful systems. So, what are some of these anti-patterns? Let's discuss them one by one. But before that, what's the Wikipedia definition of anti-patterns? So, Wikipedia says that an anti pattern in software engineering, project management, and business process is a common response to a recurring problem that is usually ineffective and risk being highly counterproductive. That's a short and crisp definition of anti patterns. So, what are the common anti patterns? Well, there's a whole catalog of common anti patterns that exist that is divided into different categories by the wiki itself. We'll go to that a bit later, but these are the most common one, and these are those anti patterns that even a junior developer can encounter in his routine work. So, the first one is SPECD code. The SPECD code anti-pattern occurs when code is poorly structured and difficult to understand. This type of code lacks modularity, separation of concerns, and readability. It is difficult to maintain or modify SPECD code because it is so difficult to understand. So, how we can deal with such a code? Code reviews and refactoring are good techniques to prevent and remove such kind of SPECD code in your code base. We can split larger blocks of code into smaller reusable chunks. And we should keep our methods, our function is small and responsible for a single responsibility. There are certain more descriptive ways that are given in the book Clean Code, a handbook of agile craft software craftsmanship by Robert C. Martin, that covers many techniques to prevent or remove such kind of spec the code. The next point is golden hammer. The golden hammer anti pattern refers to the tendency to use a favorite tool or technology for every problem, even when it is not the best choice. And this can lead to suboptimal solutions and missed opportunities to learn and grow. So, the idea is that when you hold a hammer in your hand, everything else is nothing but a nail for you. And then that hammer become a golden hammer for you. It's like a silver bullet which you try to fire in every situation. And that's the main problem with the golden hammer. It is also known as old yeller head in the sand pattern. So, when a software development team has gained a high level of competence in a particular solution or a particular product, then we refer that uniqueness and that unique competence as the golden hammer. The problem is that every new product or development effort that will come in their way, they will try to solve that with the approach, with the methods, with the tool on which they have already a mastery. They will try to use their golden hammer in every situation. But in many cases, the golden hammer is a mismatch for the problem. But then the team is still is not willing to take the extra effort to explore the additional options, except just using that or continuously nailing that golden hammer which they have in their hand. So that's not the right approach to follow. That's an anti pattern to performance. Every project should be seen as an opportunity to explore the unexplored solutions. The next anti pattern which we encounter most commonly is boat anchor. A boat anchor anti pattern happens when somebody leaves a piece of code in the code base, not because it belongs to that particular code, but because it might be needed later. And the reasoning they generally put is that when the code is needed later, it will be easy to turn it on and get it running. So they just comment it out and hope to use that in the future. It won't be turned on. So, what kind of damage can it do? Like a boat anchor, this type of anti pattern weighs down your project and keep it from moving forward quickly. Well, developers might get caught up in reading through and trying to debug code that won't even turn on in this iteration. And they will put that extra effort to understand or make some sense out of that pattern. So all this extra unneeded code bloats the code base and slow downs your build times. And if you inadvertently turn on one or more of these boat anchor anti patterns, they could cause problems such as breaking the build and adding technical risk or debt. So, in simple words, a boat anchor refers to a piece of software code or a functionality that is no longer useful or relevant but is still maintained because of legacy or historical reasons. Just like a boat anchor holds a boat in place, the term boat anchor implies that the software or the code in question is holding you back from the progress and preventing the system from moving forward. But these anchors can be expensive to maintain. They slow down the development, they introduce unnecessary complexity, and in some cases, they may even introduce the security vulnerabilities. Removing boat anchors is a challenging task for every project, and it often requires significant changes to the system or the code base. But at the same time, the benefits of removing the boat anchors are so attractive. They help in reducing the maintenance cost, they improve the performance, and they increase the overall agility for the future development. The next most common anti pattern that we have is dead code, which is also known as the lava flow. It is any section of the source code that might get executed, but its results are not used by the program. The code is unnecessary and waste processing resources. So, dead code anti patterns are heavy. They do nothing for the program, they slow down the development, increase the build times, and are difficult to maintain. It is again a situation where there is a code that is no longer executed or used in the system, and this can happen because of variety of reasons. For say changes to the software requirement, because of the refactoring of the code base, because of the introduction of the new features that render the existing code obsolete. So such kind of dead code can have a negative impact on your system. It will increase the unnecessary size of your code base, will make it more difficult to maintain and understand. And then that code can also create the confusion for the developers. They may mistakenly believe that the code is still being used and can waste their time trying to understand and modify it. So it's a very common problem that we generally face in the legacy system that we have to deal with all the time. Next, we have the God object. The God object anti-pattern happens when a single object or a class tries to do too much, and that results in a tight coupling and decreased maintainability. A God object typically has too many responsibility and it violates the single responsibility principle of object oriented programming. How we can deal with it? Apply the single responsibility principle, split such a God object into several smaller classes and split their responsibilities. God object leads to tightly coupled system, and this makes it difficult to isolate and fix bugs as well, to add new features, because developer must understand the entire system to make even the small changes. God object anti-pattern can arise for several reasons. One reason is a lack of proper system design, where the responsibility of different objects are not properly defined or discussed. Additionally, it can also happen when new functionality is added to an existing object without considering the impact on the object's overall design and responsibilities. The next most common entry pattern that we face is copy and paste programming. So, copy and paste programming is basically a habitual pattern or part of our habit or practices. And the problem occurs when the source code is copied and pasted from one location to another instead of reused through abstraction. That leads to increased maintenance cost, decreased code readability, and reduced code reusability. Sometimes copying and pasting code from other sources into your code can cause unintended problems. Simply because these samples worked for other developers on other problems, it does not mean that they can simply be dropped into your code and work without incident. So, what's the option? Instead of copying code, we can refactor it and reuse it. For example, we can take that code and put it into an abstract class, a utility class, which can access from multiple sources. We know that copying and pasting code is a tempting shortcut, but it can lead to duplicate code, inconsistency, and maintenance issues. So it's better to abstract the common functionality into reusable, accessible code blocks. So we have discussed only the most common types of anti patterns that even a junior developer can encounter in his code. But there's a whole catalog of anti pattern that exists. One can visit this wiki page, anti patterns catalog, to see that list. So, this is a whole catalog of anti patterns given by the wiki community. This catalog lists the anti-pattern in two ways. It has general alphabetic classification, and then there's a whole long lot of list of the anti-patterns. So as I said, we have discussed only the popular ones, but there are a number of anti-patterns that people face in their project, and they have documented them. Here we can get an idea what are these anti-patterns are. Then these patterns are also divided into different categories. From the point of view of the architecture anti-pattern; from the point of view of software development, the development anti-pattern. We generally discuss the development anti-patterns, so you will find those patterns here. And from the point of view of the management as well. So there are management anti-patterns too. Then there can be user interface anti-patterns and organizational anti-patterns. So this is a complete catalog of anti-patterns given by the Wikipedia, the wiki community, and one must go through these patterns to get a sense out of them and to know how to avoid them. Each of these is a link, you can explore them further and can understand. When working on software projects, it is essential to be aware of common pitfalls that can lead to anti patterns. In the next part, we will discuss the ways to deal with these anti patterns.